we begin solving problems about our current topic, that is analysis of statically determinate plane truss. This is our first example. The requirements is to determine all the forces acting on each of the members of the truss shown. We use the method of joints. So the truss is subjected to vertical load at point B. The magnitude is 40 kilonewton. And at point D, 30 kilonewton is applied in the horizontal direction. Okay, so the first step in solving the problem, pinakita ko na ito dun sa unang video clip na pinasa ko sa inyo. We check the determinacy of the truss. Kailangan alamin muna natin kung anong classification ng truss. Kung unstable yan, hindi na natin kailangan i-solve. Pag statically determinate, we can proceed for the calculation. And if it is statically indeterminate, hindi muna natin isosolve ngayon. So, simulan na natin bilangin yung members. Kung ilan ang member niya, dahil kailangan natin. So, 1, 2, 3, 4, 5 members. And for the joint, we have 1, 2, 3, 4. And for R, that is the support reactions component, we have 3. 2 for the hinge reaction and 1 for the roller support. Okay, so if you substitute the value of M and R to the equation, that is equal to 8, and twice of J, that is J is equal to 4, that is also equal to 8. So therefore, we have 8 is equal to 8. The truss is statically determinate and externally stable. So we can now proceed to calculate the member force acting on each of the members of this truss. So before we can solve for the member force of this truss, we first obtain for the support reactions, just like what we did on the beams. Guys, we assume directions of support reactions components. At point A, since we have two support reaction components, I assume that AX is acting to the left, since the horizontal force that is applied on the truss is to the right, that is the 30 kilonewton. So, ganun natin ina-assume directions ng mga support reactions natin. Wala namang ibang magbabalance dito sa horizontal load na ito maliban dito sa AX. Kaya ina-assume ko dito, to the left na siya. So, dito naman sa AY, I assume that that is upward. Then for CY, that is also upward, no? In direction. Kapag namali tayo ng assumption dyan sa mga direction ng mga support reactions na yan, magiging negative yung sagot natin after we perform the operation. Okay? So, we proceed. We will now apply equations of static equilibrium. So, nakikita natin dito, class, mayroon akong direction dyan na nakaturo dun sa right. So, ibig sabihin, if I will apply summation forces along x is equal to 0, I am considering rightward forces as positive. So, ito yun, ibig sabihin niya. No? Kaya mayroon tayo niyan. Okay, so, mapapansin natin yung 30 kilonewton is to the right, so positive, and AX is to the left, so that is negative. Okay, so solving that equation, makukuha natin yung value ng AX that is equal to 30 kilonewton, and it is acting to the left. Our assumption was correct. It is acting to the left. Then next, we apply summation moment of A is equal to 0 in order to solve for CY. If we apply summation moment at point A, we know that the 30 kilonewton will rotate in a clockwise rotation, no, with respect to point A. And for 40 kilonewton, that is also a clockwise moment with respect to point A. Then CY, that is a counterclockwise moment with respect to point A. So, lahat ng clockwise, that is positive. Clockwise, positive. Then yung counterclockwise, yung CY, negative naman siya. We equate it to 0. Then, we can now solve for CY from that equation. And that is equal to 40 kilonewton. Our assumption was correct because 40 kilonewton came out to be positive. That is an upward support reaction at point C. We assume clockwise moment are positive again, applying summation moment at point C in order to solve for AY. So AX will pass through the moment center at point C, so it will not create moment. Anong mag-create ng moment? Itong 30 kN na ito. With respect to point C, that is positive, the moment arm is equal to 8 meters. Rotate in a clockwise manner with respect to point C. Itong 40 kN naman na ito applied at point B, it will rotate in a counterclockwise direction with respect to point C. Moment arm is equal to 6 meters. Then, itong AY na ito guys, it will rotate in a clockwise direction. With respect to point C, moment arm is 13. Pansinin natin itong first term na equation, yung 30 clockwise, positive. Yung AY clockwise, positive din. Then yung third term na equation, yung 40. Yan. Counterclockwise siya with respect to point C. Okay, so from this equation, we can be able to solve for AY and that is equal to 0. Okay, so we can now check if our answer, if itong na-solve natin support reactions na ito ay tama, by applying summation forces vertical is equal to 0. We have to satisfy this equation of static equilibrium, summation forces vertical. So, yung CY natin guys is equal to 40. Then, itong AY natin is equal to 0. Then, yung downward is equal to 40. So, ibig sabihin 40 minus 40 plus 0, that is AY, that is equal to 0. So, since we satisfy summation forces vertical is equal to 0, AY and CY is equal to 0 and 40 kN respectively. Okay, so we proceed. We now consider the equilibrium of every joint. So the hint is start solving member force of the joint with no more than 2 unknowns. So titignan natin yung truss. Titignan natin kung alin sa mga joint ang mayroon lang 2 unknown. Hindi tayo pwedeng magsimula doon sa joint kung saan 3 ang unknown. Katulad nitong joint D na ito. Okay? Or joint B. Sa joint B, pwede natin makuha itong BD kaagad. Pero itong BC at saka BA, hindi natin pwedeng makuha muna yun. So, pag dito tayo nagsimula sa 3, sa joint kung saan 3 ang members na nakakonect, ang mangyayari guys is 3 magiging unknown natin. Samantalang mayroon lang tayong 2 equations of static equilibrium na pwedeng i-apply. Kaya, ang mangyayari, mas marami yung unknown natin kaysa dun sa available equation. So, hindi tayo makakasolve. Kaya, may hint doon na nakalagay. Ito yung dahilan kung bakit may hint dito. Nakalagay na start solving member force of the joint with no more than 2 unknowns. So, ibig sabihin, pwede tayo magsimula sa point A or joint A and or joint C. So, yun ang gagawin natin. Dito tayo magsisimula. Alin man dyan sa dalawa na yan. So, after solving for AD and AB, pagka kinonsider natin yung joint A, pwede na nating isunod yung pag-solve ng member force BD and DC considering the equilibrium of joint D. Dahil alam na natin kung anong AD. Pero kung uunahin natin dito, hindi po pwede. So, una, dun sa dalawa, ang unknown lang, tayo magsisimulang mag-solve. We proceed. We consider the equilibrium of joint C. So, inuuna natin yung joint C. Sa joint C, guys, mayroon tayong 2 unknown, that is BC and CD. So, here's now the equilibrium of joint C. Ito. Papansin niyo, ito yung CD, guys, Tapos, mayroon tayong BC, tapos mayroon tayong support reaction, vertical CY. Pero, yung CD, naka-incline siya. Anong gagawin natin kapag kaganyan? Kailangan natin i-solve yung component, vertical and horizontal. So, paano natin makakukuha? Ito yon guys, So, ito yung CD natin, member CD natin. Yung dimension niya, that is, yung height is 8 meters, and yung base length is 6 meters. So, this is a right triangle, therefore, we can solve for this distance, that is square root of 6 squared and 8 squared. So, the vertical component now, guys, is equal to 8 divided by this value of CD. Then, for the horizontal component, this is equal to 6 divided by length, itong length na ito. Okay, so that is equal to 10 if we solve. Yan. Pagkasinolve natin, that is equal to 10. So, pag ginawa natin yung class, itong vertical component natin is 0.8 of CD, at saka yung horizontal component naman is 0.6 of CD. So, papalitan na natin itong value ng vertical component that is 0.8 at saka yung horizontal naman that is 0.6 of CD. Okay, so we assume that CD is acting toward joint C. Anong ibig sabihin yan? So, ina-assume natin na compressive itong CD na ito. Compression, under compression siya. Ngayon, kapag nag-negative yung answer natin after performing the operation, ibig sabihin, it is not acting toward the joint, but it is acting away the joint. Katulad nitong BC na ito. Na-assume naman natin that this is acting away the joint. This is under tension. Na-assume natin na tension yung BC. Samantalang yung CD, that is compression. Yun ang ibig sabihin ng acting away the joint and acting towards the joint. Pag nag-negative, yung sagot after performing the operation, our assumption was incorrect. We proceed. We apply now equations of static equilibrium. Summation forces vertical and summation forces horizontal. We assume that upward forces are positive and applying summation forces vertical is equal to 0. So, itong 40 kN na ito, that is upward positive, and yung 0.8 CD na yan, that is downward negative. Ito yung equation na yan. So, from this equation, guys, now we can be able to solve for CD, and that is equal to 50 kN. So, since this is positive, CD is compression, or that is a compressive force acting at member CD. Okay, so next, we apply summation forces along horizontal is equal to 0. So, BC is acting to the left, the direction is to the left. We assume that rightward forces are positive. So, since BC is leftward force, that is negative, and the rightward force, that is 0.6 of CD, that is positive. So, from this equation, we can be able to solve for BC, knowing that CD is equal to 50 kN. Ito yung nasolve natin kanina sa unang equation. So, if we replace the value of CD with 50, we can solve for BC, and that is equal to 30 kN. And our assumption was correct since 30 kN came out to be positive, that is under tension. Okay, so that is how we apply equations of static equilibrium, summation forces vertical and horizontal at every joint. That is what we call method of joints. We are considering the equilibrium of every joint of the truss. We proceed to the next free body diagram. Okay, so these are important notes. Prinubay ko ito, guys, para kung sakali basahin niyo, no? So yung pinaliwanag ko dito, ito na rin 'yon. Itong pinaliwanag ko kanina, ito na rin 'yon, itong note na ito. So binigyan ko kayo ng kopya nito para pwede ninyong balikan kung ano bang ibig sabihin ng mga sign na nandyan. Okay, so we consider the equilibrium of joint B. The number of unknowns is equal to 2, AB and BD. So, joint B daw tayo. Joint B. AB and BD ang unknown natin. So, joint B tayo. Kino-consider natin yung joint B. So, dalawa lang unknown. Bakit? Kasi meron na tayong value ng BC. Okay, so balikan na natin yung free body diagram natin. Ito yung equilibrium ng joint B. So, alam natin that there is an applied downward force at point B, that is 40 kN. And for BC, na-solve na natin ito, that is equal to 30 kN, and that is under tension. Kaya nakikita nyo, it is acting away the joint. Okay? So, yung AB, since yung BC is acting to the right, kailangan yung AB, assume na natin na to the left siya. Okay? So, ganun natin kino-consider yung mga directions sa mga equilibrium natin at every joint. Kapag ito solve tayo ng problem, guys, kailangan balansehin na natin ito. To the right na nga ito. Tapos gagawin din natin to the right yun. Di ibig sabihin, wala nang babalance dun sa force. Kaya, ito dapat i-assume na natin to the left. Okay, so itong BD naman na ito, upward siya since yung 40 kN is downward dito. Okay, so we can now apply equations of static equilibrium. Again, summation forces vertical and summation forces horizontal. So, meron tayong assumption, upward forces positive. Masosolve natin yung BD, ito. So, kung unang tingin pa lang, nakikita na natin, walang ibang babalance dito sa 40 kN na ito, kundi yung BD. So, BD is equal to 40 kN, and since it is acting away joint B, that is under tension. Okay? So, dito naman sa pangalawang equation, ito. So, we can be able to solve for AB. So, that is leftward. Kasi nga, yung BC rightward na. So, that is also equal to 30 kN. Since 30 kN is positive, that is under tension. Okay? Acting away joint B. So, dito mayroon ulit ako mga important notes dito, no? Basahin nyo ulit. Gusto ninyong malaman itong mga nandito para maging basihan ninyo, no? Sa mga direction na inilagay ko dito. Okay, so next we consider the equilibrium of joint A. So, number of unknowns is equal to 1. So, unknown na lang ito kasi iisa na lang siya. Okay, so at joint A, pag tinignan natin yung truss, oo nga naman, iisa na lang unknown, itong AD na lang. Bakit? Kasi nasolve na natin yung AB, considering the equilibrium of joint B. So, AD na lang ang unknown. So, balikan na natin. So, yung AD guys, that is an inclined member. Kaya kailangan din nating masolve yung vertical at saka horizontal component niya. Okay, so, dito guys, sinolve na natin yan. So, replace na natin yung horizontal and vertical component ng AD. So, paano ba natin nakuha yun? So, ito yung member AD. So, yung dimension natin is 8 meters yung height. Yung namang base length, no? Yung distance niya, yung horizontal direction, no? That is 7 meters. So, yung distance na ito, guys, that is equal to square root of 113, no? So, we take the square root of this distance of this value, 80 square inside the square, that is square root of 113. So, yung vertical component ng AD is equal to 8 divided by square root of 113. Yung namang horizontal component that is equal to 7. Yung distance na ito divided by itong distance na ito. Square root of 113. So, that is 0.753 and 0.65 na AD respectively. Okay, so we can now proceed to the calculation. We will now apply summation forces vertical. Okay, so upward forces are positive, so we have 0 kilonewton. Ito yung reaction at point A natin. Alam natin kanina na 0 yung reaction natin. So yung downward 0.753 AD should be equal also to 0. That is to satisfy the equation of static equilibrium summation forces vertical. So if 0.753 is equal to 0, therefore AD is equal to 0. Yan. Kuha natin yung value ng AD that is equal to 0. And we can also check if our answer is correct by applying summation forces horizontal naman. So, pag tinignan natin ito guys, mayroon tayong leftward force dyan, 30 kN, that is equal to AX. No? Yung reaction natin dun sa A. Pero, alam natin, itong value ng AB na ito guys, that is also equal to 30 kN. So, if we apply summation forces along horizontal, 30 na yung leftward, 30 din yung rightward, ibig sabihin, yung horizontal component ng AD, that is also equal to 0. At mangyayari lang yon kung AD is equal to 0. So therefore, tama yung sagot natin kanina doon sa una nating equation, AD is equal to 0. Ayan, so AD is equal to 0. Then we can move to joint D. Ito, para ma-verify natin kung tama nga naman yung ating nakukuhang mga sagot. No? So, joint D. Dito, if we consider the equilibrium joint D, masatisfy kaya natin ang summation forces vertical and horizontal. Yun ang tanong, Pag nagawa natin yun, ibig sabihin, tama yung mga sagot natin na nakuha dun sa member force from the calculation na pinerform natin, So, ito na yung ating free body diagram. So, alam natin may 30 kN applied at D, then yung horizontal component ng AD, then yung vertical component ng AD. Ito naman yung CD natin, mayroon din siyang horizontal component, mayroon din siyang vertical component, then mayroon tayong value ng BD. Solve natin yan, and that is equal to 40 kN. So since AD is equal to 0, yung horizontal component niya is 0, vertical component niya is 0. And since nakuha natin kanina dun sa CD is 50 kN, alam natin na ang horizontal component is 30 kN, and yung vertical component is 40 kN. So 40 upward, 40 downward, that is equal to 0. Then 30 to the left, 30 to the right, that is also equal to 0. So from the free body diagram of joint D, we can be able to satisfy equations of static equilibrium, summation forces vertical and horizontal. So, satisfy natin, ibig sabihin yung ating mga sagot natin na nakuha is correct, Okay, so bilis lang guys, tingnan natin yung ito. Ito na yung na-solve nating mga forces dun sa truss, So, Itong AD na ito, that is 0. Itong AB na ito, guys, ano, 80, that is acting away the joint. So that is under tension. Ang ibig sabihin nitong yan, yung direction na yan. Ito din, 30 kN, acting away the joint din, yung direction ng forces. So tension yan. Ito naman, acting towards the joint. So joint D yan, acting toward, joint C ito, acting toward din yun. So yung 50 kN na ito, that's under compression. Okay, so tension, then ito compression, then another tension. No? So it is acting away joint B. Ito naman, acting away joint D. So, ganun natin tinitignan yung direction niya para malaman natin kung that is under compression or under tension, yung ating mga member force. So, mahalaga na alam natin yun, guys. Ano, pinaliwanag ko na yun sa introduction natin ng analysis of statically determinate truss. Okay, so that's all for this first example. Next time, solve ulit tayo ng panibagong example. So, thank you and keep safe to everyone.